Hi guys, today we're going to be talking about circles and distance. We'll start with distance, or in other words, length. Distance and length mean the same thing, and we find both of them by using the Pythagorean theorem. A squared plus b squared equals c squared. So what you can see here are the steps written out with an example right beneath it. So we're going to follow those steps while we complete the example. It says find the length of AB with coordinates A and B. Whenever I see the word length, I'm going to write myself a note that it's a squared plus b squared equals c squared. So here I'm going to first find change x and change y. This will give us steps 1 and 2 at the same time. Then I'm actually just going to stick a third column on here, Pythagorean theorem. So remember that when we calculate change means to subtract. So take your first x value and your second x value and subtract them. 4 minus negative 5. That double negative, of course, turns to positive, so now we have 4 plus 5, which gives us 9. Then take your y values and subtract them. Go in the same order that you just did. So we have negative 2 minus 6. This gives me negative 8. When we plug into Pythagorean theorem, these values get plugged in for a and b. It doesn't matter which one gets plugged into which, as long as you don't plug them in for c. So now we have 9 squared plus 8 squared equals c squared. You'll notice that I dropped the negative with the 8, and that's because if we take a negative times itself, that's what squaring is, it becomes positive always. Just like 8 times 8 is also positive. Okay, so now we have 9 squared plus 8 squared. We're going to type that right into the calculator. 9 squared plus 8 squared, and we get 145 equals c squared. In order to undo squaring, we just simply square root. So now we have c equals square root 145. And we can leave it just like that. The only time we cannot leave it like that is if it says to write it in simplest radical form. The next part says that we have regular polygons, which means that all sides and angles are congruent. Regular means all sides and angles are congruent. We have some basic shapes that you do need to know the number of sides for. A pentagon has 5 sides, hexagon has 6, octagon has 8, and decagon has 10. Now there are other shapes in there, of course. A septagon is 7, nonagon is 9, but these are the 4 common shapes that Common Core questions focus on. From here, we're going to move into talking about circles. Circles are written in this form, center radius form, as x minus h quantity squared plus y minus k quantity squared equals r squared, where hk is the center. So you'll notice that in order to go from the equation to writing the center, we have to take the value of h and k and negate them. Negate value for the center. To find the radius, we have to take the square root of r squared, which makes sense. Square root of square cancels out, so now we are just left with r. If we're given the center and an endpoint, use the change x, change y Pythagorean theorem table. That's what we just did up above to help us find the radius. Sometimes they ask you to find the diameter though, so you have to remember that diameter is 2 times the radius. And vice versa, radius is diameter divided by 2. On 3 Common Core state tests that have come out so far, they've all had a question in which we have to complete the circle, because they give you an equation that looks like this: x squared plus y squared plus cx plus dx plus e equals 0, where c, d, and e are just numbers. So we have some steps here, and we're going to actually use these steps on the next page when we do a problem together. So go ahead and flip it, and I'll walk you through these steps as we work on the next problem. So number 1 is a Common Core question that says, what are the coordinates of the center and length of the radius of a circle whose equation is x squared plus 6x plus y squared minus 4y equals 23? So the first step that's written on your steps on the previous page says to move the constant e to the right side. The constant e is the number without any variables, no x's, no y's. That constant is actually already on the right-hand side for us in this first problem. It doesn't always happen, but sometimes it does. That first step also says, as you move it over there, regroup so that x's are with x's and y's are with y's. This problem started that way anyways. They put x squared with 6x, they put y squared with 4y. So now our next step is to put some plus blanks in here. X squared plus 6x plus blank plus y squared minus 4y plus blank. Then we have equals 23. And because we put a plus blank on the left side for the x's and on the left side for the y's, we need to get two of them on the right side, just to keep the equation balanced. So in order to find the value for this first plus blank, I'm going to focus on this 6x right here. This is my b value for the x terms, because typically we go a, b, c. b is always attached to the x term, the linear term. So we take that b value of 6, and we divide it by 2, and then we square it. This is the process of completing the square. You cut it in half, and then you square it. So this gives us 9, which means if I put a 9 on the left side of my equation, I also need a 9 on the right side of my equation. From here, we're going to focus again still on the x's, x squared plus 6x, and now we have a plus 9. And now we're going to do something called factor, add, multiply. So we set up two pairs of parentheses, x in the first spot of both, and then we find two numbers that add to 6 and multiply to 9. Our factors of 9 are 1 times 9 and 3 times 3. So the only pair that helps us add to 6 is 3 and 3. And they both must be positive in order to add to a positive 6. So now I condense this by saying that we have x plus 3 quantity squared. When you take something and multiply it by itself, that becomes squared. Now we're going to move on to the y's. We have y squared minus 4y plus blank. So again, take the linear term, the negative 4, divide it by 2, and then square it. Remember, when you square negatives, they always become positive. You should never be putting a negative value in your plus blanks. So in this case, we have y minus 4y, or y squared minus 4y plus 4. And I put that plus 4 on both sides of my equation to keep it balanced. So now again, we're going to think add, multiply, focused on just the y's now. So we have parentheses y, two numbers that multiply to 4 and add to negative 4. So factors of 4, we have 1 times 4, 2 times 2. The only pair that will help us add is 2 and 2, and they both, in this case, must be negative to add to a negative 4. So now we have y minus 2, parentheses squared. I'm going to stick a plus sign in here, and then on the right-hand side, I'm going to add these three numbers up. 23 plus 9 plus 4 gives me a total of 36. So this first question is asking what's the center and the length of the radius. So remember, in order to find the center, the h and the k, we take these values inside the parentheses and we change their sign, negate them. So positive 3 is now negative 3, negative 2 is now positive 2. So our center is negative 3, positive 2. Then we take a look at the radius and we say, okay, if I have a 36 over here, I need to take the square root of it, which gives me 6. So we have negative 3, positive 2, and 6. Choice 4. Number 2, again, Common Core question, says the endpoints of one side of a regular pentagon are negative 1, 4, and 2, 3. What is the perimeter of the pentagon? So before we talk about how to find perimeter, let's talk about what a regular pentagon is. Remember, regular means all sides are congruent, and pentagon means 5 sides. So in this case, we have 5 congruent sides. And it's asking for the perimeter, which means we need to add all sides. Which means I need to find the length of one side and then add them all together. So length, again, remember, means a squared plus b squared equals c squared. So we're going to do our change x, change y, Pythagorean theorem table. If it's helpful, you can label your coordinates as xy, xy. That way you know which ones to subtract from which. Go ahead and fill out this table independently. So I found c equals the square root of 10. Now that is a choice, but remember we need to find the perimeter, which means that we are adding up all 5 sides, and all 5 sides are square root 10. So we have square root 10 plus square root 10 plus square root 10 plus square root 10 plus square root 10. Well, we have 1, 2, 3, 4, 5 of them, so that's a total of 5 square root 10. Choice 2. Number 3, again, Common Core question that says that we have a center of circle Q has the coordinates of 3, negative 2. If circle Q passes through R, 7, 1, what is the length of the diameter? So length, again, a squared plus b squared equals c squared. I'm going to just sketch this for you so you can get an idea of what it's telling us. We have Q at 3, negative 2, and R at 7, 1. And this is a circle around Q. So if we were to calculate length between Q and R, this would give us the radius. But they're asking for the diameter. And remember, we talked on the front page of your notes that diameter is 2 times the radius. So once we get our answer, we have to go back and multiply it by 2. So we're going to start with change x, change y, Pythagorean theorem. Go ahead and calculate this all independently. So I found c equal to 5. Remember that this is just the radius. So now I have to take and multiply that by 2, which gives me a value of 10. So number 3 is choice 3. Go ahead and flip it once you have it. Alright, so we have 2 more problems together, and then you'll be able to move on to your practice independently. The next one is very similar to what we did first together, where we have a crazy equation in general form, and we need to find the center and the radius of this circle. So again, first step is move the constant to the other side. And as we rewrite, we're going to group x's with x's and y's with y's. So we have x squared minus 28x plus blank. Then plus y squared plus 4y plus blank equals negative 191 plus blank for the x's plus blank for the y's. So to calculate this value, remember that we take the linear term, the b, cut it in half, and then square it. Go ahead and type that into your calculator. You should have found 196. So I'm placing that in both plus blanks. one on the left, one on the right. Now we're going to add multiply. So 2 pairs of parentheses, x, x. Now it's going to take you a long time to list all of your factors of 196, so I have a trick for you. The last time when we did this, you may or may not have noticed, but all we have to do is take this b value and cut it in half and carry the sign. So negative 28 divided by 2 is negative 14. This goes in both places. And you can check your math by saying, okay, negative 14 times negative 14 is positive 196. Remember, we were multiplying to 196. Good. Negative 14 plus negative 14, it adds to negative 28. Perfect. So we have our factors by simply dividing by 2. This condenses to x minus 14, quantity squared. Then for the y's, we do the same type of thing. We have our b value of 4 divided by 2 squared. This gives us 4 in both places. You can factor, you can think about add multiply, or just simply, again, divide by 2. This gives you y plus 2, y plus 2. So we have y plus 2 quantity squared with a plus sign, an equal sign, and on the right hand side, these 5 numbers sum to 9. Now we're not done because it does ask for the center and for the radius. So remember that you have to negate the values, negative 14, positive 2, negate them, switch their signs. And then for the radius, we have to take the square root of that value, meaning we get 3. Number 5 says, in the coordinate plane, vertices of triangle RST are blank. Determine the perimeter in simplest radical form. Perimeter means to add all sides, which means we need to find length, or, in other words, Pythagorean theorem. So what we're going to do is make a bigger table than what we've been seeing. We have change x, we have change y, Pythagorean theorem, but then we need another column over here on the left-hand side called sides. We have side RS, ST, and RT. If you think about plotting this triangle, you have R, then S, then T. So you just envision those side lengths, RS, ST, RT. What I like to do is write the coordinates beneath each of these letters, because it helps me when I'm calculating my changes. So R is 6, negative 1. S is 1, negative 4. The next one, S again, 1, negative 4. T is negative 5, 6. R is 6, negative 1. And T is negative 5, positive 6. Now we can go through and calculate our changes, and in order to do that, you just have to look up and down with these coordinates now. Instead of moving your eyes back to the original problem, and you might, mix up what letters or what numbers you're supposed to subtract with which, you can just simply look over here on the left side of your table and say, okay, my x's, I have 6 minus 1 for RS. My y's, I have negative 1 minus negative 4. So this gives me 5 and 3. Then for my ST, we have 1 minus negative 5. I'm going to let you finish the rest of this table. I want you to plug these into Pythagorean theorem once you're done. I will be doing it on the video independently, but you should try this on your own at this point. If you need more time for your table, please pause the video, otherwise move forward with me. So I found my changes plugged into Pythagorean theorem to give me c equals square root 34, c equals square root 136, and c equals square root 170. Remember, what they're asking for is the perimeter, so we need to add all three sides together. When you add radicals, it's different than adding just numbers, because you have to break the radicals down before you can add them. It says simplest radical form. So what we do is find a perfect square from our perfect squares list. We come up with this list by taking numbers and multiplying it by itself. For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, so on and so forth. So what we do is we find one of these perfect squares to go in these numbers. Now sometimes no perfect squares go into these numbers, and that's okay. That means it's already in simplest radical form. You don't want to force it. However, you do need to check to see if any of these numbers go into each of these. So what you do is you start with the number that you're trying to break down, and you find the number closest to it but not bigger than it on your list. So for 34, I would start with 25. And in my calculator or in my head, I would try to do 34 divided by 25. This gives me a decimal or a fraction that's not a whole number. We're looking for whole numbers here. So then I try 34 divided by 16. That, again, is not nice. 34 divided by 9, not nice. 34 divided by 4, not nice. And we kind of ignore the 1 here. So what we do is we keep this as square root 34. It's okay if it doesn't break down, but you still have to test them. The next one, take 136 and divide it by 64. Not nice. 136 divided by 49. Not nice. Divided by 36. Not good. Divided by 25. Not good. 136 divided by 16. Still not good. Divided by 9. Okay, let's try 4. Oh, good. So hopefully you were testing those in your calculator. You're not thinking that I'm crazy. So we have square root, square root. 4 came from our perfect squares list, so we put that first. 34 is what gets multiplied by 4 to make 136, so we put that second. Square root 4 now turns into a 2. Square root 34 cannot be broken down further, so we carry it down. Remember that we still have a plus sign in front. Now we're going to try 170. Go through your perfect squares list, see if 170 can be broken down. If not, it's okay, but we need to check. Pause the video while you do this. Come back to me when you're done. Alright, so you should have found that nothing goes into square root of 170, so we're just going to carry it down, which means that now perimeter is square root 34 plus 2 square root 34 plus square root 170. So now I have 1 square root 34 and 2 square root 34. That's a total of 3, because 1 plus 2 is 3, square root 34. It kind of works like 1x plus 2x is 3x. Okay, you just keep the value inside the radical, add the numbers on the outside. Plus square root 170. This here is our final answer for the perimeter. Alright, if you need to go back and review any of those questions that we did together, feel free to rewind the video. Otherwise, you're going to move forward into your practice before an assessment. Let us know if you have any questions. We're happy to help you. Good luck.